how to solve a quadratic inequality, right? And we did it by graphing. Right? So just a quick review of what that was, because it's important. You got to be able to tell the difference between what we did Monday and what we're doing today, because they're just a little bit different. All right, so on Monday, if I gave you a parabola, let's say, that looked like this, and I said that's the number, that's 1, and this is 2, okay, and then this is some equation, okay, I don't know what the numbers are in it, but it's something like that. All right, then what we learned how to do was if we wanted to know when is this graph greater than 0, in what intervals. So when we talk about intervals, guys, when I put in the two x-intercepts, it divides the graph into 3 sections. Okay, a section to the left of 1, a section between 1 and 2, and a section to the right of 2. So each one of those is known as an interval. Okay, the A interval would go from negative infinity to 1. The B interval is between 1 and 2, and the C interval is from 2 to infinity. All right, each one of those is known as an interval. So where is the graph greater than 0? Well, greater than 0 means the graph is above the x-axis. So the graph is above the x-axis here and here. So the two sections where it's positive would be the interval at A, it's positive, or, yes, folders on the wall, the right one. And then the right one, that is your other right. Should be right in the front. Got it? Okay. And then it's greater than 0 outside the other critical point, which would be from 2 to infinity. So any number in this interval and any number in this interval would satisfy this inequality. Satisfy, let's say I picked a number from this interval like 3. So if I took 3 and I substituted into my equation, I'm going to get an answer greater than 0. All right, so that's if the graph was asking us, where is it greater than 0? Okay, then the other option is, well, what if instead of this being a greater than, that symbol was a less? Okay, come on, computer, catch up. There we go, less than 0. Okay, then you're looking for the part of the graph that is negative. Okay, so that's going to be, now the graph is less than 0 because it's below. So the interval where the y values are below the x-axis or less than 0 would be between 1 and 2. All right, so that's what we did that's what all this was about here. Problems 1 through 6 on the review, and then I think we did one of them from the assignment in question 2 on the assignment. Actually, what you're looking at here is question C from the assignment. but it's the same idea. This one was asking where is it less than 0? So it's less than 0 and here. So the interval would be between the two x-intercepts. So I use the zero function on the calculator, and I found these two numbers. Okay, questions on this, guys? I'm kind of going through it pretty quick. Are we okay on what to do, how do you find it graphically? Don't be shy, guys. If you're not sure, ask. Okay. Now what we're going to look at is the discriminant. All right, so this is page 132. Okay, now here, this is what's really important. This graph, this is the graph of the discriminant. It is not the original graph. Okay, what I drew up here, original parabola, this is the graph of the discriminant. So they're two different things. Graph of the original, graph of the discriminant. All right, so what I did was I took this is the original. This is my original parabola. So we'll put original. Okay, this is the discriminant of the original. Discriminant. The original graph, or the original parabola. Okay, the graph that you're seeing right there, that's the graph of the discriminant, not the original. This is discriminant. Not the graph of the original quadratic. Okay, now you got, if we take the x-intercepts here, this x-intercept is -1, and this x-intercept of the discriminant is 2. So I'm going to put those right here, -1, -2. All right. Okay, so here's where this is a little different than what we did here. All right, since this is the discriminant, okay, this graph is getting divided into 3 intervals. Okay, the one interval goes from -infinity to -1 on the x-axis. That's this interval that I'm shading in green. And the other interval right here in green, that goes from 2 to positive infinity. All right, and then the interval that I'm highlighting here in yellow, that's between the two. That's the interval from -1 to 2. So these are, and then you got this space in between the x-axis. or the x-intercepts. All right, now what I'm going to do is make what is called a sign graph. Okay, so down here, these are we call these critical values or x-intercepts. Look at the blue graph. Is it positive or negative in the interval from negative infinity to negative 1? It's positive. My graph is positive. So what this part means here, it means the discriminant is positive because it's the graph of the discriminant. It's not the graph of the function, it's the graph of the discriminant. So I'm going to put a plus sign right here. Now, what that plus means is the discriminant is greater than 0. It's positive. Discriminant is positive. It's the same as that. Now, in between the two, the discriminant is negative. So in between here, let's see. Let's draw an arrow. In this interval, the discriminant is negative because the graph is negative. So between negative 1 and 2, I'm going to put a negative sign. What I'm creating and it's telling where the graph is positive and where the discriminant is negative. Okay, so let's see. Now in let's see, right? So here the discriminant is negative. Okay, that's the yellow part. And then the other green part, positive. So here, delta is positive. Okay, so I'm going to put a plus sign there, and delta is greater than 0. All right, questions on how I'm getting that part? All right, now here's how you interpret it. When you look at these signs here, when delta is greater than 0, the original quadratic, well, let's write it like this here. If I said where does this equation have two distinct equal roots? Okay, so this is going to happen in the intervals where the discriminant is positive, where delta is greater than 0. Because to have two roots, the discriminant has. Okay, so I just look at my sign chart. The discriminant is going to be positive, negative, infinity, and 1. Negative 1. Or, all right. So now it says, where is the equation have no real roots? So for it to have no real roots, this is going to be in the intervals where the discriminant is less than 0. In the intervals where delta is less than 0. So there's only one place where delta is less than 0, and that is between -1 and 2. Okay, so K is in this interval, or we could write it like this. It's the same thing. So K values between -1 and 2. This original parabola has no real solutions. If K is outside the 2x intercepts, then it has 2 real solutions, the original. And if the value of K is between the 2x intercepts, it's going to have, where was I? It's going to have no real roots. And if it's equal to the x-intercepts, it's going to have 2 equal roots. So all we're doing is we're looking, where's the graph positive? Okay. Then this one was where you're looking for the x-intercepts. And then this one you're looking for, where is the discriminant negative? That's how you're using, so we never graphed the original equation. Instead, we graphed its discriminant. So we used the discriminant to identify values of K that generate 2 distinct roots, 2 equal real roots, or no real roots. All right, questions. This is probably something that's new for you folks. All right, so we're going to solve this equation. So here's what this is doing. If I gave you these questions yesterday, you'd have to solve 3 discriminants in order to get them, or 2 in this case. Now we're just able to do, if we just look at the discriminant. All right, so find the values of K that make this statement true. Typo there. Okay, find the possible values of K such that this has 2 distinct roots. All right, so what I'm going to do is I'm going to graph, instead of graphing that original, I'm going to graph the discriminant. All right, so if I was doing this on my calculator, A in this case is 1, B is -3K, and C is 1. Okay, so if I was going to graph this on my calculator, I'd go to Y1, and I would type in B squared. So on my calculator, I can't use a K, I have to use an X. -4 times A times C. So I'd be typing in this equation. That's this equation right here. All right. And then what that'll tell us what these 2 points are right here. Those 2 points we're going to put right down here on this number line. Okay, as soon as we get them. All right, so to do that, first of all, is the discriminant, if I go outside the two x-intercepts, is the discriminant positive or negative? Okay, so this section and this section, my discriminant, delta is positive, delta is positive, it's greater than 0. And then in between, delta is negative. And then at each one of these, delta is 0 and delta is 0. Okay, now which part are we looking for if we're looking for two distinct roots? Yep, we're looking for where delta is positive. So this is here, delta's positive, here it's negative, here it's positive. And at these 2 points, delta's positive, delta's negative, delta's positive. And then at these little guys, delta is 0. Okay. Now you can do this. We could type this into our calculator and we could use the 0 function and we could find out what these two numbers are. Okay. Another way of finding where those two numbers are is just solve this equation. Okay, so if we solve this for 0, that's going to give us our x-intercepts. That's going to generate the x-intercepts. So since my computer is super slow right now, I'm not going to do it on the calculator. I'm just going to solve it. So we're going to add 4 to both sides. Okay. Following along, Aiden? All right. So I'm going to add 4, add 4. Then I'm going to divide by 9. And then I'm going to take the square root. And both of those are perfect squares, so this is a friendly, this is going to be plus or minus 2 over 3. Okay, so one of these is negative 2/3, and the other one is positive 2/3. Okay, now to answer the question, let's see, right over here. Find the values of k that make this true. Well, k would have to be between, or let's see, k is in that. See how slow it is. I'm overpowering this poor thing. Okay. All right. So what this means, k is in either this interval, negative infinity to negative 2/3, or k is in the interval 2/3 to positive. Now that little funny looking e right there, that just means is a member of. So k is in a member of this interval or a member of that interval. And any of those values would give you, it would have two distinct x-intercepts. So down here, where it's positive, let's see, anything in here, you got two distinct roots. Okay, when the discriminant's negative, you have no roots. When it's positive, you have two distinct roots. Distinct just means different roots. And for where it's equal, you have two equal roots. So that's how you interpret these values. This one would be two equal roots. So if it's positive, two distinct roots, those two areas. If it's negative, you got no real roots. And then if it's equal, you got two equal real roots. So later on, if you guys go on to the next course in this, when you're studying derivatives in calculus, you're doing the exact same thing. You're deciding where's the derivative negative, where's the derivative positive, and then that's telling you different things about the original graph by analyzing the derivative. We're analyzing the discriminant. Okay, can I move that? All right. So this one's asking, where does it have no x-intercepts? Okay, so we're going to graph the discriminant. Okay, and in this case, A is k, B is negative 2k, and C, so here's A, here's B, and C is this whole thing, 3 plus 2k. And then we're going to put, that's going to be this graph over here. Okay, so let's see. B squared is going to be negative 2k squared minus 4 times A times C. Okay, so it's 4k squared minus, now we're going to do all of this at once. 4k times 3 plus 2, 12k plus 8k squared. That goes right in here. So and now I just simplify it. Now this negative, guys, affects both of these. Okay? That's inside those brackets. So this is really this. Right? So I'm going to have negative 4k squared minus 12k. And that's the equation that goes into your calculator. So y1 would be, what I would type in is 4x squared minus 12x on my calculator. So that's the graph over here. Okay, now from this graph, we can tell what the x-intercepts are. One x-intercept is 0, and the other one is negative 3. So on my sign chart, I put 0 and negative 3. Okay. Now okay, so what sign am I going to put down here to the left of negative 3? Positive or negative? Pardon me? Negative. See, the blue graph is negative. So over here, the discriminant is less than 0. So I write negative. Okay, this is the discriminant. Okay, write it like this. Okay, discriminant is negative. Now, in between those two, the discriminant's above the x-axis. So the discriminant is positive. And then to the right of 0, the discriminant is negative again. And then at these two, the discriminant is 0. All right, so no x-intercepts occur when delta, which situation creates no x-intercepts? Negative. I should have just wrote negative, not negative 1. Okay, so when delta is negative. So we got delta is negative. Here, delta is positive. And at this number, delta is 0. Okay, so we want to, the two regions we're interested in are this one and this one. This means no roots. This means no roots. Okay, in between them means two roots, no roots. Right here means two roots. And this guy means two equal roots. So all I do on this problem, guys, is I look at what this is. No x-intercepts, that means no real roots. Okay, so my answer is going to be negative infinity down to 3 or 0 to infinity. Those are the values of k that would create no real roots. So being able to analyze a graph like this is a fundamental skill in the next sequence of this course. We're analyzing the graph of the discriminant to find the values that create no real roots, two equal roots, and two distinct roots. All right, anything on B here? That question. All right, now the only thing that's different in this next section here where it says solve the inequalities algebraically, we don't use the graph anymore. Okay, so the next examples in here, we're going to do it algebraically. And I guess we'll do that tomorrow, since we only got about a few minutes left. So this assignment will get pushed to tomorrow and due Monday. Okay, so I don't think you guys seen this before.